All right, as I am writing on these notes, you are writing in your note packet, and once you are finished with this, you may start on your homework assignments. I'm going to do both part 2 and part 3 since part 2 is pretty short. So the top section is just review. Remember, when you're adding two binomials, you can drop the parentheses and just combine like terms. So this is 2x plus 3 plus x minus 6. Your 2x and x is 3x, and your 3 minus 6 is negative 3. Number 2 is a little bit more complicated. You have to distribute the negative 2. You also have to distribute the negatives. This becomes negative 2x minus 8 minus 3 minus 2x. Negative 2x minus 8 minus 3 minus 2x. Negative 2x and negative 2x is negative 4x. Negative 8 minus 3 is negative 11. So those are those two answers. Okay. What this section is really about is adding and subtracting radicals. And just like adding and subtracting fractions, they have to have the same radical in order to combine them. So you have to combine like terms. And if you need to break down the radical to get it to be the same as the other one, you have to do that first. So what I mean by that is look at this. Square root of 3 and the square root of 3 are the same. All I do is add it on the outside. So 4 is 6, and it stays square root 3. You do not add the root 3 and the root 3. It just stays like a like term. Okay. Number 4, you got to pretend there's a 1 there. Square root of 5 and square root of 5 are the same, so 1 minus 3 is negative 2. So this is negative 2 root 5. Now number 5, I have root 3 and root 48. So root 48 and root 3 are not the same. I know I need to change root 48 because 3 is already simplified. So root 48 is 16 and 3, which is 4 root 3. Okay, so now I have the same. 2 root 3 plus 4 root 3 is 6 root 3, and then you're done. Number 6, I have 12 and 27. Neither of these are simplified, so both of them need to be changed. So this is square root of 4, square root of 3. So this is 2 root 3. And 27 is square root of 9, square root of 3. So this is 3 root 3. Okay, but you gotta be careful because I have this negative 5 out front, so I need to multiply the negative 5 times the 2. So this is negative 10 root 3 plus I have 2 out front and 3 out front. So when you multiply those together, you get 6 root 3. So I have negative 10 root 3 plus 6 root 3 is negative 4 root 3 is your final answer. Okay, so that is it for day 2. There is a worksheet on this. I believe it's only 12-ish problems. You can either stop and do that now, or you can keep watching this video, fill out the next section of notes, and then do both worksheets at the end. I don't care which way you do it. All right, here is part 3 where we multiply and we divide. And I'm not super sure what happened on example 2. I wonder if yours looks different. I'm going to pause and see if it does. That was magic. I paused it and unpaused it and it all showed up. So that was nice. Okay, so just a little recap before we get to our next property for multiplying and dividing. The square root of 9 is 3. The square root of 4 is 2. 3 times 2 is 6. Okay, also, guys, you could have done 9 times 4, which equals 36, and the square root of 36 is also 6. Either way works. Square root of 144 is 12. 12 times 3 times the square root of 49, which is 7. And 12 times 3 is 36. And 36 times 7, I do not have memorized. But I'm going to use one of your calculators that's been sitting on my desk and you still don't know it's gone. 252 is the answer to number 2. Number 3 is 4 times the square root of 2 times 3 times the square root of 10. When you multiply, you can just multiply the outer terms and the inner terms. So 4 times 3 is 12. Root 2 times 10 is root 20. But you are not done yet because root 20 is not fully simplified. So that's 4 and 5. So you have 12. Gotta remember to bring that down. 12 times 2 root 5 is 24 root 5, and then you're done. Number 4, this is kind of the distributive property with a radical. So this root 2 times 4 is 4 root 2 plus 2 root 3 times root 2 is root 6. And then you got to try to combine like terms. So I have root 2 and root 6, which neither of these can be simplified any further. And you can't combine when the radicals are not the same. So that would be your final answer in number 4. And lastly, number 5. This is basically 2 squared and root 7 squared. So 2 squared is 4. The square root of 7 squared is just 7 because the square root and the square cancel each other out. So 4 times 7 is 28. Now, the last property in section 9.1 is your properties of multiplication. So when you have the square root of a over b, you can separate it into the numerator and the denominator. So this is super helpful when your numerator and your denominator are perfect squares, but they're stuck under one radical. So for example, number 6, the square root of 25 over 16, you can split it the square root of 25 or the square root of 16, and then you can get 5/4 pretty easily. Number 7, you can split it into the square root of 5 over the square root of 36. Square root of 5, we don't know what that is. We're just going to leave it alone. The square root of 36, we know is 6, so we're done. Same thing, square root of 63, don't know what that is, but I do know that it can be simplified. So the square root of 63, I want to say is 9 and 7. Does that sound right? 9 times 7 is 63? Yeah, it is. Okay, square root of 9 times the square root of 7. So 63 is 3 root 7. And then the square root of 100 is 10. Now, you have to check to make sure your whole numbers are simplified. So my 3 here and my 10, to make sure they can't be simplified any further. In this case, they cannot. So you are done. 3 root 7 over 10. Number 9, the square root of 27 is the square root of 9 times the square root of 3, which is 3 root 3. So I have 3 root 3 over negative 3 times square root of 100, which is 10. So I have 3 root 3 over negative 3 times 10 is negative 30. And this is what I was talking about with the simplification. I have 3 and negative 30. So 3 over negative 30 simplifies to 1 over negative 10. So your final answer would be 1 root 3 or just root 3 over negative 10. You could also put the negative sign out here or out front. One of those situations will work. Now, if you'll notice, if you look at the denominators in 6, 7, 8, and 9, not a single one is left with a radical in the denominator. That is because you cannot leave a radical in the denominator. So when you simplify something and you're left with a radical in the denominator, you need to do something called rationalizing. Okay, so rationalizing, oh my gosh, I stopped clicking and it just kept going. Rationalizing the denominator is when you get the denominator, or when you get the radical out of the denominator. For example, if you have 2 over root 3, to rationalize the denominator, you multiply both top and bottom by what's in the denominator. Okay, 2 times root 3 just gives you 2 root 3, and then root 3 times root 3 is root 9, which is really 3. I should probably make that one more step. So root 3 times root 3 is root 9, but then that simplifies to 2 root 3 over 3. Okay, same thing on 11. You don't need to multiply the 2, but you do need to multiply by the root 5. So root 3 times root 5 is root 15, and 2 times root 5 times root 5 is 2 times root 25, which is 2 times 5, which is 10. So this is root 15 over 10. Number 12, you've got square root of 8 in the denominator, so multiply by root 8 over root 8. So I have 10 root 8. Root 8 times root 8 is root 64, which is 8. Now I need to simplify here. 10 over 8 simplifies to 5 over 4. So I have 5 root 8 over 4. Ooh, one more thing. Root 8 is not done, is it? So I'm going to back this train up. I'm going to erase what I just did. Because root 8 simplifies into root 4 times root 2, which is 2 root 2. So 10 times 2 is 20 root 2 over 8. And then 20 over 8 simplifies to 5 over 2. So I have 5 root 2 over 2 as my final answer. All right, number 13, I have 4 and 27. So I'm going to split this as a square root of 4 over the square root of 7. Square root of 4 is 2, and the square root of 27 is root 9 times root 3, which is 2 over 3 root 3. But what can you not have in the denominator? That's square root. So then you need to multiply the bottom by root 3 and the top by root 3. So we're left with 2 root 3 over 3 times root 3 times root 3 is root 9. Keep simplifying. 2 root 3 over 3 times 3, which is 9. So I have 2 root 3 over 9. Whew! You just have to keep going until everything is simplified and what is in your denominator is not a square root. All right, number 14. If you look at 5 and 45, neither of those are perfect squares. But if don't you agree I get 1/9? Yeah, and those are both perfect squares, so this problem just got a whole lot easier. Square root of 1 over square root of 9 is 1/3, and you're done. So if you can simplify what's in here before you split the numerator and denominator to make your life easier, by all means do it. Okay? All right, last one, number 15. I have 1/2 times the square root of 32 over the square root of 75. 32 over 75 is fully simplified, so I can't use my little trick. So I'm going to have to split everything. So I'm going to work over here because I have a feeling I'm going to need the room. So 1/2 times, I'm going to split it, the square root of 32 over the square root of 75. 75 I know is 25 and 3, which is 5 root 3. The square root of 32 is 16 and 2, which is 4 root 2. Okay, I'm not done yet because this square root of 3 is still in the denominator and I need to get it out. So root 3 times root 3, there's my multiplication. So root 3 times root 3 is root 9, which is 3. So this turns into 5 times 3. And then my numerator turns into 4 root 6. So I'm going to rewrite this down here. I have 4 root 6 over positive 5 times 3, which is 15. Okay, still not done yet because root 6, oh, maybe I am done. Yeah, because root 6 is fully simplified, and 4 over 15 is also fully simplified. Oh, I thought that problem was going to be a lot harder. Congrats. Okay, you have 2 worksheets to work on. 9.1 day 2 and 9.2, oh my gosh, 9.1 day 2 and day 3. And those need to be done tomorrow. Have a good day.